Okay guys, this is your assignment on compound angles. So reading the first question here, by writing 75 as a compound angle, a sum of two angles. A compound angle is a sum or a difference of angles, and without using a calculator find the cos of 75 degrees. Okay, so that just boils down to saying it's the cos of 45 degrees plus 30 degrees. Okay, now it's a cos of a sum. The sum plus produces a minus. A cos produces a sinusoidal pattern of cosine, cosine, sine, sine. And the angles get dropped in as 45, 30, 45 degrees, 30 degrees. Okay, moving on from there, we got cos of 45 is 1 over root 2, and the cos of 30 is root 3 over 2. Okay, and the sine of 45, and I'm just thinking now it might look nicer if I write this as root 2 over 2, and then sine of 30 is 1 over 2. And just stepping back here, I'll put this as root 2 over 2. So it looks to me like we're getting root 6 minus root 2 all over 4. Moving on to the next question. Without using a calculator, express the tan of 75 in surd form. So the tan of 75 degrees is equal to the tan of 45 degrees plus 30 degrees. So we have the tan of a sum, and that's equal to, there's a fraction, and we know there's a plus up here, and we have tan of 45 degrees plus the tan of 30 degrees over 1 minus the product of the sums, the product of the tans. Okay, so we start plugging in algebraic expressions, numerical algebra if you like, and we get, what's the tan of 30? The tan of 30 is 1 over root 3. So the tan of 45 is 1 over root 2. No, it's not. The tan of 45 is 1. The tan of 30 degrees is 1 over root 3. 1 is still 1. Minus 1, you can leave it out. When it's part of a product, you can leave it out. And the tan of 30 is 1 over root 3. So taking this way, I'm going to tidy it up by multiplying across by root 3. So root 3 plus 1 over root 3 minus 1. Okay, and out of curiosity we'll plug it into the calculator, the tan of 75, and see what it says. Okay, there's a little bit further I can go with this. We can do a thing called rationalizing the denominator. To do that, you root 3, you need to get rid of surds in the denominator. Okay, you don't want any more surds down there. And to do that, any surd, compound surd, can be rationalized by multiplying above and below by what it's called its conjugate, which its surd conjugate, which is, you just change that sign. Okay, to justify that we have to do that there as well. So what's interesting here is the cross products will disappear and you'll end up with 3 take away 1, which is 2. Okay, another way of seeing that is whatever is in that square root, subtract the square of this, which in this case is just subtract 1. Okay, up above, we might want to multiply that out, giving us 3 plus 2 root 3 plus 1. So we're ending up with 4 plus 2 root 3 over 2. But 2 distribute, the division of 2 distributes, and we get 2 plus root 3. And you have 2 plus root 3. Okay. Okay, moving on. Without using a calculator, express the sine of 105 degrees in third form. Sine of 105 degrees. Okay, so we're kind of looking for a sum that gives 105 degrees. Well, 90 and 15 doesn't really work for us because it's just not suitable. 60 and 45 is the way we want to go. The reason 90 and the 90 is fine, but the 15 is not part of one of our special angles. So we must find a sum of special angles that adds to 105. If it'll help you, you might want to write them out. It's a simple case of 30, 45, 60, and maybe sometimes 90. So these are the angles that are under consideration. Okay, and this combination works. So we want the sine of 60 plus 45. It seems to make sense to put the big one at the beginning. So now we're going to try and write down the sine of a sum. So the sine of a sum is equal to the sum of sine, cosine, cosine, sine. And dropping the numbers in 60 and 45, we end up with 60, 45, 60, 45. Now we're substituting in values. The sine of this is root 3 over 2. Root 45, cos of 45 degrees is 1 over root 2. Okay, or root 2 over 2. Plus the cos of 60, which is a half. And the sine of 45, again, root 2 over 2. So we have 4 dividing in a common manner to root 6 plus root 2. And I don't think it would go any further than that. But what's lovely is, rather than check it back in a book, you can just check what your calculator says, because it's going to take it to its simplest form. So the sine of 105 is equal to root 6 plus root 2 all over 4. Done. Okay, next up we have that we're given what the sine of alpha and the sine of beta is. Okay, let's write them down. The sine of alpha is 5 over 13. I'm just going to do a triangle as well. Probably don't need it, but just do it anyway. So we have 5 here and 13 here. Actually, that makes this 12. And the cos of beta, different angle, altogether is 4 over 5. Which does make this 3, by the way. So... and beta is less than 45 degrees. Okay, fine. Express the sine of alpha plus beta in form of a over b, where a and b are integers. Do not use a calculator. Okay. Fine. Okay, so we have 2 things to write down. Oh, I'm getting, sorry, I'm going to write this question again. So get the sine of the sum. Okay, so the sine of the sum will be equal to, in this case I think it's no harm in writing out a bit of, giving myself a bit of something to guide myself. So it'll be equal to the sum of sines on the outsides, cos's in the middle. Or sine, cos, cos, sine, if you want to remember it that way. Okay, so we're going to go alpha, beta, and the plus here give us a plus here. So now we have 5 over 13 multiplied by 4 over 5, which is 4 over 13, plus And the cos of alpha. Now here's where my reference triangles turn out to be very handy. Because without my reference triangles I wouldn't know what the cos of alpha is. But right, I've already done this. The cos of alpha is 12 over 13. And the sine of beta is now the cos. I wrote that wrong. Okay, that should have been a 4 and that should have been a 3. Everything else is fine. I knew I wasn't going to be writing down 4 over 5 again. I want to be writing down 3 over 5. Okay. Excuse me. So that's 20 and 36. They have a common denominator, so I can go ahead and add the numerators. 20 and 36 is 56. And does 13 go into that? 20 and 36 is 56 over 60. Well, 4 goes into both of them. That can't be right. That can't have 65. Okay, and I would check on the calculator that that doesn't reduce, that there isn't some 13. No. Okay, so that's how many 13s? That's 5 13s. But there's never any harm, if you're not sure, there's never any harm in checking on a calculator that the calculator doesn't want to reduce that fraction. Okay, because if you don't know your number theory and you don't absolutely know that there isn't some sneaky, a kind of large prime number going into both of them, or other common factors that you didn't spot, then you'll end up in trouble. Okay, that's that one done. Okay, so continuing on now, we're going on to question 5. Okay, so given that alpha and beta are acute angles. Okay, let's go with a reference triangle for the sine of alpha is 7 over 25. 7 7 is 49. This is 24. And there's a story behind that, what I just did. But basically, if you want a gap of 2 here and you have an odd number, any odd number, let's just do a triangle here. We put that odd, make it odd, what do you want? 7, 3, 5, 7, make it 5. So then 5 5s is 25, and you can split that. 5 5s is 25, and then you want to split that into two numbers that are 1 apart, 12 and 13. Okay, and 13 goes there and 12 goes here. Just do one more example. We put 9 here, 9 9 is 81, well that'll be 40 and that'll be 41. You can always do that, it's just a quick way to calculate them. So I know this triangle very well, and coming along here we have alpha is here. Okay, and by right, really, when you see sine alpha is 7 over 25, you've kind of moved the question forward by doing the reference triangle. When we see the cos of beta, look, there it is there, that triangle. When we see that the cos of beta is 5 over 13, we move that forward into a reference triangle with a beta in it. So the cos has this length over this length is 5 and 13. Okay, and our beta is here. And as I say, that makes this 12. Now it's completely not to scale, but that doesn't matter. Without using a calculator, express the sine of the sum and the tan of the sum. So we're asked to check what the sine of the sum is, and then we'll do the tan of the sum. Now I'll just move what I have here on to the next page to give myself a bit of space, and we shrink them up. And that's the kind of policy you can use during your exam as well, especially if you get extra paper. It's just after doing some synthesis you can end up having used up a lot of space, and you might want to shrink your current knowledge and your current understanding of what's been asked, and give yourself some room. Okay, so we have 7, 24, 25 with alpha here, and we have beta here, 12, 13 and 5. And higher up you go with the maths, the less important it is that you need that you need the scaffolding of having the scale right. You're certainly not going to be thinking about this on a concrete level. There's no way you can operate at that level. So we have sine of alpha plus beta and the tan of alpha plus beta are the questions that we need to address. So let's kick off with the sine of alpha plus beta. So we write down the formula. Plus means plus. It's a sine cos sine. It's an alpha beta, and we can start substituting. And hopefully we can read these straight off our reference triangles rather than doing out a table. The sine of alpha is 7 over 25. The cos of beta is 5 over 13. The cos of alpha is 24 over 25. And the sine of beta is 12 over 13. Okay, so this common theme keeps reoccurring where we seem to spot what that's worth. Now they said not to use a calculator, but they mean don't use your calculator for a trig. But having said that, let's bring this down to 12 25s is 3 4s. It's 325 there, okay? And that's common. So then we're talking about 12 12 is 144, so that's 288 here. 288 and 35, no idea. Well, I can do pen and paper. Nobody can stop me. And, well, this is 31, 32, 32, 5. Whoa, would you look at that? 32, 5. Okay, so that's equal to 1. Which makes me think, oh, this had to be 90 degrees. Wow. Okay, let's check that. Let's add inverse